Hello, my name is Kyle Reihner, and I am in Section 4 of the Chemistry 110N lab, and this is my video lab report for the copper reactions and percent yield experiment. In this experiment, it began with just pure copper. From there, compounds were added to it, and their reactions were described on page 12 of the chemistry lab manual in the detailed observation sheet. Also in the Chemistry 110 lab manual was this list of compounds as well as their descriptions. So, using these two sheets, it could be determined what would be in each box. When the entire chart was filled, the mass of the initial and the mass of the final were calculated and the percent yield was found. So, step 1, hydrogen nitrate was added. When hydrogen nitrate was added, a brown-red gas was given off. Going to the table, the only brown-red gas is NO2. To double check, nitrate is present. NO2 is nitrite, so it very much makes sense that NO2 would be present. From there, when that occurred, water was added. When water was added, a greenish blue liquid appeared before it finally turned just blue. Going to the chart, a bright blue aqueous solution, which is similar to a liquid, was CuNO32, or copper 2 nitrate. Going back to this chart, nitrate is present, so it very much makes sense that copper 2 nitrate would be there. When that is completed, sodium hydroxide was added. When sodium hydroxide was added, it turned into a chunky, bright blue solution. So, going back to the chart, CuOH2, it's royal blue, and it's a solid. So, that seems as if it would work. Going back to the chart to check, OH is hydroxide, CuOH has hydroxide, so it very much makes sense. From there, it is also apparent that salt must be present because it was in Na. Going to the table, the only source of Na is in NaNO3, so it must be present. When all that is determined, heat was added. When heat was added, it went from being blue to black, and all of the salt was at the bottom, and there was a clear liquid on the top. So, going to the chart, a black salt is CuO, or copper oxide, or copper 2 oxide. So, it is present here, and this is solid. Now, as I said before, there was liquid that was clear on top of it, but since heat was added and no chemical was added, there couldn't be a new substance. As a result, water must have been the colorless liquid. From there, H2SO4, or hydrogen sulfate, was added. When hydrogen sulfate was added, it turned back to a blue liquid. Going to the chart, once again, sulfate must be present. There's zinc sulfate and copper sulfate, but it is known that it must be copper, so it must be CuSO4, or copper 2 sulfate, which is a bright blue salt, aqueous. Also, once again, water is present. From there, zinc is added. When zinc is added, it gives off a colorless gas. Now, colorless gases the only colorless gas on this sheet is hydrogen gas, or H2. So, H2 was present. Now, when zinc was added, obviously zinc itself must have been present. And here it is, the solid. So zinc with a positive 2 charge is present. From there, nothing happened to get rid of the sulfate. So, going to the chart, a white salt, which makes sense because we said there was a whitish clear solution, is ZnSO4, or zinc sulfate. Which is aqueous. Now that all the compounds have been put into their right spots, it's time to do calculations. Going to the table on page 12 of the lab manual, before the experiment was exercised, the initial mass of the copper and the initial mass of the evaporating dish were taken. When the experiment concluded, the mass of the evaporating dish with the recovered copper was taken. To find the amount of copper recovered in grams, the initial mass of the evaporating dish must be subtracted from the final mass of the evaporating dish. So, 49.860 grams minus 49.483 grams yields 49.860 minus 49.483 gives 0.377 grams. So, 377 grams, that is the final mass of the copper. Comparing that to the initial mass of 0.504 grams, divide the two to find the percent yield. 0.377 grams divided by 0.504 grams, the grams cancel, times 100%, 0.377 divided by 0.504 equals 0.748 times 100 equals 74.8%. (74.8% of the original copper came back. Due to the fact that only 74.8% of the copper was retrieved, it is clear that experimental error was present in this experiment. Experimental error comes in two forms: greater than 100%, which is any error that will cause the final mass to be higher than the initial mass, which should not be possible, or there's less than 100% error, which is what I suffered from, which is anything that will cause the final mass to be less than the initial mass in an experiment. In this experiment, an example of a less than 100% error occurred in step 3, according to the procedure on page 11 of the lab manual. In this experiment, when the solution was being heated, it was stirred. On the stirring rod, at the bottom, which was inserted into the solution, there were solids on the bottom. So, it is clear that some of the solid was taken out of the solution when the stirring rod itself was taken out. As a result, on accident, some of the substance was lost, which would yield less than 100%, which is what occurred in this experiment. As for greater than 100% error, while I did not suffer it, there is plenty of opportunity for it to happen in this experiment. In this experiment, decanting occurred, which is when liquid is gently poured out so as not to disturb a solid. When some of the liquid was poured out in step 7, which was when 5 milliliters of methanol was added, some of it stuck to the solid. So if solid came out, that would have been very negative towards the percent yield. So some of the liquid was inevitably left inside. While it was left out to dry, it is very possible that some of it was kept inside the solution when it should not have been. It should have only been the copper. So as a result, some extra mass was put in there, and the yield was over 100%.